Good morning, dear students. Hope you are doing good. We are discussing the unit 5th unit as part of the curriculum E1. Today, we will discuss the technology, one of the technology to treat the water. Before that, we have seen different types of water treatment technologies so far. And now we are discussing and we are focused on individual parameter that influences the quality of water. Whereas in the previous cases, in the stages, we learned how to treat water at bulk quantities, either in sedimentation, coagulation, and even in filtration. Now we are discussing the treatment methodologies for individual parameter based and for individual parameters, or as individual chemicals, which shows or as which are influencing the quality of water. Dear students, we have seen the quality of water when we can say that water is in good composition. In third unit itself. The third unit, we have seen various chemicals, various physical factors, and various other related components. When all those are satisfied, we can call the water is acceptable and we can give the permission, or else we can give the accessibility of that water to the public. As part of water treatment, apart from the bulk treatment in the name of sedimentation, coagulation, filtration, and all, we need to check the individual parameters also. Whenever we found that one particular parameter is crossed its permissible level, we must treat that water in order to bring that particular in order to bring back that particular parameter to get the accessibility of water, or as to give the accessibility of water for the public. Understand? Likewise, we have crossed the stage of treating water in all the categories like sedimentation, coagulation, and all. Now we are in the stage to treat individual chemicals. Dear students, you know, in the third unit, we have seen various chemicals in the name of IS 10500 2012 standards. What it is speaking to us, nothing here. When we have a look in the sessions, what we discuss, this is the thing I would like to focus now. This is the slide. See here, in this slide, you are clearly visualizing that the acceptability limit in the sense, when you can give the accessibility of water to the public, as long as all these chemicals are within the limit. If they cross their limit, we need to bring them back to the position of acceptable limit. See, today I'd like to discuss one particular component, that is this fluoride. The fluoride is very much essential component for the well-being of human beings, because the fluoride is a major component in the formation of teeth, bones, and also it plays vital role in metabolism. See here, but almost in the entire world, somewhere other way, the fluoride is the biggest problem. In the groundwater. Even our neighbor district, in the Algonda district, there is a problem with fluorine. There is a problem with this fluoride in groundwater. And huge research went on to find out the solution, or else to bring back that fluoride concentration in groundwater into an acceptable limit, that is one. See, this fluoride is the biggest problem almost everywhere. That's what I want to speak now. See here, in the previous classes, we have seen how to remove iron and manganese and how to remove color and order, we have seen. As per the curriculum, we are moving, right? As per the, the content in the syllabus book, we are discussing the individual parameters, right? Today, we'll discuss about fluorine, or is how to remove this fluoride concentration and how can we add this fluorine to the fresh water, as it is the essential component for the metabolism of human beings, of course, for the quality of water. See here, now we'll go to that topic, that is fluoridation. We are in second, fifth in it, the topic name is fluoridation and defluoridation. Simply, I just mentioned important points over here. See, as you have seen that the fluorine acceptability limit is 1 mg per liter. If the water is not holding even that acceptable limit, that means less than that acceptable limit, we need to add the fluorine to the water, and we need to increase the fluoride concentration water for the quality of water, or as it is essential component, whereas for human beings, for the formation of teeth and bones. See here, how can we add this fluoride concentration to the water? Simply, there are different salts, there are different components to add, or is to increase the fluoride concentration in water. Why we should add? We discuss now, because that is the most essential component. And how we can add? Simply, of course, there are different mechanisms, dry feeders, and of course, dry feeders in the powder form, and also in the solution form and saturated forms. See here, we can add this fluoride either in the powder form or in the solution form. See here, addition of liquid fluorine to water, that is the first point. How much? See, it depends on the temperature. Less than 18.3 Celsius of temperature, 1.1 to 1.3 ppms. Of course, the constant is, the 1.1 to 1.3 and 18 point, but the temperature 18.9 to 26.6 degrees. 0.8 to 1.0. That means we can say that above 18.3 Celsius, we should add the concentration at 0.8 to 1.0. And if it is the constant, if the temperature is greater than 26.7 degrees Celsius, we must add 0.5 to 0.7 in the range. See here, and one more thing I would like to ponder here is how there are I mean, what are the forms of fluoride, or how can we add this fluoride concentration to the water? Simply, fluorine can be added. Fluorine can be added in different forms. One is CaF2. One is CaF2. That is one form. Another one is, see here, another one is sodium fluoride and silica fluoride. Likewise, we can add. Of course, there are other fluoride concentrated components also there, which we can add. But mostly I just mentioned here three such components. Three components which we can add to the water to increase the concentration of fluoride for the well-being of, or else to get back the quality of water. Understand? See here, when can add? I said that why we should add. Why we should add? Simply to get back the concentration, or else, as it is the essential element, we are adding fluoride. I mean, how much we can add? Simply 0.5 to 0.7, as it is the country, as we are in the country where the temperature is about 26.7 degrees. Am I right? See here, coming to the next technique, defluoridation. Here, defluoridation in the sense, see here, in the fluoridation we have seen, the addition of fluoride concentration. Now, here, how much we are added? 1.1 to 1.3 ppm, where when the temperature is less than 18.3 degrees Celsius, when the temperature is above 18.3 degrees Celsius to 26.6, we can add 0.8 to 1.0 ppm. Whereas if the temperature is above 26.7 degrees Celsius, the temperature is 0.5 to, I mean, concentration is 0.5 to 0.7 ppm. See here, and what we can add, CaF2 and sodium fluoride. And sodium fluoride is it is an odorless, free-flowing material, and it is available in the powder of crystals, and it is expensive, of course. It is a little bit expensive. Next one is silica fluoride. Silica fluoride obtained as byproduct of purification of phosphate rocks. From where we can get it? Silica fluoride we can obtain as byproduct of purification of phosphate rocks. See, in all the cases, of course, there are different different combination of fluoride components are there. I just mentioned only three. That is good: CaF2, sodium fluoride, silica fluoride. And the temperature is, we have based on the temperature, the fluoride will be added to the water. If it is less than 18.3 degrees Celsius, 1.1 to 1.3 ppm, and above 18.3 degrees Celsius, 0.8 to 1.0, and greater than 26.7 degrees Celsius, it is about 0.5 to 0.7 ppm. I just mentioned here only the important topics, important points here. Fluoridation, as it is a very simple topic, just adding a fluoride concentrated components to get back the concentration of fluorine into an acceptable limit, that is 1 milligrams per liter. Now is the defluoridation. What is defluoridation? Simply removal of excess fluoride. This is the problem what we are most of the places facing. Even Nalgonda also, the problem with groundwater is fluoride, excessive fluoride concentration. What is defluoridation? Simply removing excess concentration of fluoride is called as defluoridation. There are different techniques to remove this fluoride concentration from the water. Among them, today we are going to discuss one particular, highly accepted method, that is Nalgonda technique. Nalgonda technique, the name itself, the technique name itself, Nalgonda techniques. See, there are different models to bring back the concentration of fluoride in the groundwater. Today we are discussing one well accepted technology, that is Nalgonda technique, and it is developed by NEERI, National Environmental Engineering Research Institute, Pune, and the process is adapted for defluoridation of potable water at domestic as well as community level. See, this is the technique. See, the removal of fluoride concentration from the water is called as defluoridation. There are different techniques to remove the fluoride concentration from the water. Among them, Nalgonda technique gained good attention, and it is proven that it is the best method to remove the fluorine concentration from the water. What is exactly like? What is the mechanism exactly behind this technology? Before that, we'll discuss what are the ingredients we are supposed to add to remove the excess fluorine. The first one is aluminum salts. Aluminum salts, in the sense, see, I mentioned there are two types: aluminum sulfate, alum, or aluminum chloride, or even the combination of these two gives more flux. What are the components we needed in this method? Aluminum salts, first one; second one, lime; third one, bleaching powder. These three are the things, and these three are the components which we need for conducting this experiment. See what is happening here. Simply see mechanism, rapid mix, and this is the lime is added, alum is added, and rapidly we are mixing. See, this is the raw water. Fluctuation, just try to remember, in the third unit we have seen, we just added the optimum dosage of coagulant and allowed for fluctuation, where the rotatory arm is adjusted to rotate for fixed RPMs. By doing so, suitable amount of flux will be absorbed on the top of the water body. Simply here, raw water is entering into the drum, to the container where the lime and alum is adding. After 1 minute, rapid mixing, because of rapid mixing for 1 minute, and it's a fluctuation will be observed. See, at that particular time, it is subjected to send to the sedimentation tank. See, because of that flux formation, the rapid mix provides mixing of chemicals, fluctuation, gentle agitation. See, by doing so, in this method, turbidity, color, odor will be removed along with the reduced bacterial load. And the lime is making the residual element does not remain in treated water. See, sedimentation. Here we are here. See, in this container, we are just allowed for rapid mixing where the flux is forming. And once it reached this stage, sedimentation, see here, permits setting flux loaded with fluorides and other contaminants. See here, this is allowed to settle. This is allowed to settle the flux for a period of time. They see here, once it got sedimented, that will be subjected for filtration. After that, the rapid sand filter will enter into the scenario where, see here, the supernatant, that means the water after, the sediments will be settled at the bottom, and the supernatant, see here, supernatant will be collected and will be subjected to filter. Which filter it is? Rapid sand filter. From this, the water will be subjected or sent to the overhead tank. From that overhead tank it will go for supply. See here, what is exactly happening? Fluctuation, sedimentation, filtration, disinfection. These 4 steps are observing. Fluctuation, where it is happening? See here, fluctuation, gentle acidity. Taken, see, the raw water is entering into the container, and as a rapid mixing is happening, rapid mixing is subjected for rapid mixing for 1 minute. Slowly the fluctuation is absorbed, and at the time, see, we have just added alum and lime. Alum in the sense, see here, alum in the sense, aluminum sulfate alum or aluminum chloride, or combination of these two for removing fluorine from water. How much concentration lime? For 1 part, 20th part of lime will be added. See here, 1/20th of the dose of aluminum salt. This is the combination. And here, as the water is entering from the rapid mixing chamber, else drum, into the sedimentation tank, allowed for settling of flux for how much time? 90 minutes. After 90 minutes, the supernatant will be collected and will be subjected for filtration. Filtration in the sense rapid sand filters will be adopted here. Through the rapid sand filters, the water will be collected and that will be sent, the same will be sent to the overhead tank. See here, advantages. Regeneration of media is not required, easily adaptable, economically it is cheap, and we can treat large quantity of water. Chemical, all the alums and all the chemicals are readily available. No handling of caustic acids and alkalines and all. This is simple to design and high efficient in fluorine removal. It can be applicable for both batch mode and continuous mode. Along with the removal of fluorine, the unwanted color, odor, turbidity can be removed in this step, and it requires minimum electrical and mechanical equipment. It provides defluoridated water at uniform acceptable quality. One more time, advantage. Regeneration of media is not required. See, media, regeneration is not required. Washing and using regeneration is not required. See, adaptability, easily we can adapt. It is cheap, relatively cheap. No technical, high technical expertise is required. No requirement of high-end technical expertise. And the fourth one, easily and readily available chemicals are adapted. It is simple to design and high efficient in removal of chlorine concentration. When we adapted this fluorine removal, automatically the unwanted color, odor, and turbidity will be removed and provides fluoridated water at uniform acceptable quality. This is about the advantages. Of course, there are few disadvantages, high formation of sludge. Of course, when compared with this positive advantages, it gain, because of these advantages it gain world concentration, and the name is Nalgonda technique. See here, developed by NERI, National Environment Engineering Research Institute, Pune, Nagpur. See here, in this technique, basically 4 steps are observing: flocculation, sedimentation, filtration, and of course bleaching. Bleaching is, we are, for disinfection, we are as in a disinfectant, we are adding this bleaching powder to reduce the bacterial load. So in the first case, we have seen fluoridation, addition of required fluoride concentration to the water. How we can add this fluoride? Simply in the form of CaF2, sodium fluoride, and silica fluoride. See how much we can add. See, if based on the temperature, we will add the fluoride, we will increase the fluoride concentration. If the temperature is 18.3 degrees Celsius, 1.2, 1.3 ppm. If it is the temperature is above, 18.32, between the 26.7 or as 26.6, we can take more particularly. The range is 0.8 to 1.0. Whereas if the temperature is greater than 26.7, 0.5 to 0.7 ppm of the fluoride concentration will be added, so that it will come to the limit which is acceptable, so that the water can get the permission for public supply, or else we can give the accessibility of water for public supply. This is about fluoridation. And defluoridation in the sense removal of fluorine. We have seen just now what is the technology lied behind this Nalgonda technique. See, 4 steps: flocculation, sedimentation, filtration, and disinfection. That means bleaching powder. Where high efficient in removal of fluoride concentration in the water. Hope you understood. If any doubts, please contact me, either message, phone, or mail. Thank you.